Okay, let's look at exam 3, version A, right? Number 1, right? So we have this rational function given, right? Then we want to take a bunch of limits and find asymptotes, right? So let's do that. All right, so limit of f of x as x approaches infinity, right? When x approaches infinity, all you really have to do is focus on the leading terms on top and bottom. So you can see that leading term on top is 3x squared, and the leading term on the bottom is x squared, right? So we can write it as, so this is going to be just a limit, right? Still goes to, x goes to infinity, right? Then we just look at the leading term on top, which is 3x squared, and leading term on the bottom is x squared, right? Then simplify. Luckily you have x squared on top and x squared on the bottom. We can cancel them out, right? So you get the limit of constant 3 as x approaches infinity, right? But the limit of constant is the same constant, so limit is going to be just 3, right? So that was part A. Right, part B, right? Same function, but the x approaches 1 from the left, right? So for this one, we're going to use the factored out version of the function, right? If you look at it, you can see that on top there's a factor quantity x plus 2. There's the same quantity x plus 2 is down here. So before we take the limit, we can eliminate by cancel those out. Right, now we can just take the limit, right? So limit as x approaches 1 from the left, right? So what's left was 3x plus 1 over x minus 1, right? So what you do is just plug in and see what happens. So it's a 3 times 1 plus 1 over, right? So this one you have to be careful. So you're going to plug in 1, but from approaching from the left, right, minus 1, right, which is going to be, right, so 3 times 1 is 3 plus 1 is 4. You have 4 on top, right? So you have a 1 minus 1 is 0. So you have to, but you have to determine from which side. Right, so 1 with a negative sign, you can think of this as something slightly smaller than 1. So let's say like a 0.9999, right? So minus 1 is going to be slightly negative, right? So you can see that 4 divided by something very, very close to 0 is going to have a huge magnitude, right? The sign-wise, you have a positive on top divided by the negative, so it's going to be a negative infinity, right? So that's part B, right? Right, part C, right? So it's the same function and the limit as x approaches negative 2, right? So let's do that. So this is going to be a limit as the x approaches negative 2 from the positive side, right? So we can use same function, so it's a 3x plus 1 over x minus 1, right? Then just plug in, right? So 3, x goes to negative 2, so 3 times negative 2 plus 1 over, right, negative 2 minus 1, right? So this is going to be equal to, right, 3 times negative 2 is negative 6, plus 1 is negative 5, right? Then you have negative 2 minus 1, so it's going to be negative 3, right? So negative signs cancel out, so you have 5/3, right? is the answer. All right. Let's do part D. Part D, we want to find horizontal and the vertical asymptotes. All right. So part A will indicate that since the limit, the limit at infinity is equal to 3, so we know that the horizontal asymptote is y equals 3. Right? Right, then part B actually tells you that, right, part B, right, tells you that since the limit as x approaches 1 from the left goes to negative infinity, this indicates that there is going to be a vertical asymptote there. So vertical asymptote is x equals, right, this number 1. X equals 1 is the vertical asymptote, right? And part C tells you that since the limit as x approaches negative 2 does not go to either positive infinity or negative infinity, which means that the x equals negative 2 is not a vertical asymptote. Right? So we have horizontal asymptote is y equals 3, and the vertical asymptote is x equals 1. All right? That's it. I hope that this was clear.